This lecture will cover the statistics you need for the Psych AP exam. Now, this is not statistics for a statistics course. You cover the information here probably in just the first few weeks of, like, say, statistics AP. But at the same time, and you don't need to know a ton in terms of statistics for the AP exam, but the things you do need to know, you need to know it fairly well. So there isn't much to cover today, but there is stuff that can be very important when it comes to looking at the data from research itself. So one thing that we can do in terms of measuring the data is create a histogram. A histogram is essentially a bar graph, but it's a bar graph that can sometimes look at multiple variables. So say, for example, you're creating a bar graph of your participants, and you have the heights of your participants on the y-axis. You have the ages of your participants on the x-axis. You might have separate bars for each age group, but additionally, within those age groups, you may also have separate bars for men, women. Maybe you look at ethnic groups or things like that. So the histogram essentially is a bar graph, but it's a bar graph that can basically have multiple bars for each part of the bar graph itself. Uh, and I will attach a picture of a histogram to the assignment as well, in case it's a little confusing from this lecture. Now, when you have your data itself, one thing that you can do is you can use measures of central tendency. These are simple measurements that's designed to help you elicit strong conclusions to your data itself. One of the easiest things to use is to take all the numbers in your data and to find the average. That is the mean. The mean is the average of all the numbers. And a lot of times, this is a really great number to use because it really shows, the average of all the responses to all your participants, or all the data that you have for each participant. But sometimes data sets can be skewed. For example, let's say we were talking about a person, we were talking about an athlete, a basketball player, and we were looking at their points per game. And in 5 games, they scored 5, 6, 8, 9, and then 37 points in one game. Their average would be somewhere in the mid-teens, but that isn't necessarily reflective of their talent. So sometimes a better number to use is the median. And the median is the exact middle number. If you line up all the data or all the numbers numerically, the median would be the one in the direct center. Finally, sometimes if you're looking at preferences or things like that, the mode can be an excellent measurement as well. And the mode is the number that occurs most frequently. So if you have, like you're asking, let's say, the salaries of adults, and, you give them a bunch of different choices, and out of 15 people, 8 of them said that they make $50,000 to $60,000 a year, then that would be the mode, because that is the one that is answered most frequently. Measures of central tendency are pretty simple, and there we have the 3 main measures of central tendency: the mean, median, and the mode. Measures of variability looks at the differences and the variance within scores. One easy measurement is the range. The range is essentially, you take the largest number in your data set, you subtract it from the smallest number in your data set, and you've got the range. So it's basically, what is the overall from the lowest to the absolute highest? How many numbers, or what measurement is that from the lowest to the highest in terms of your data? And then that would be the range. The standard deviation is a complicated measurement. And in fact, on the next slide, I will give you the steps to finding the standard deviation, though almost always it is given. And the standard deviation is basically a number that's used to measure the variance of numbers and their distance away from the mean. So what that means is, if we're looking at, let's say, a normal bell curve, our mean here is 100, and we're going to come back to this normal bell curve in a little bit. And one standard deviation would be any numbers within 34% of that mean. 2 standard deviations is this orange section here, and that is obviously two full standard deviations away from the mean. And what it's doing is it's measuring the variance in numbers and their distance away from the mean itself. And so certainly, if you have more numbers within your data sets that are closer to the mean, then you're going to have a much bigger standard deviation, such as in the case of this first standard deviation right here. The z-score is a score that is a score that I'm sorry, I'm having lost my train of thought here just for a second. Excuse me for one moment. I'm sorry about that. The z-score is basically the measurement of the number of standard deviations that a data set is away from the mean. So, for example, if we look at our normal bell curve again, we can see that a z-score of 1 would be any number from 100 to 115, but also any number from 85 to 100. A z-score of 2 would be these numbers of 70 to 100, and then 70 to 85, and 130 to 115. It's basically the measurement of the number of standard deviations that a data point is from the mean. Finally, we have the p-score. And the p-score is something that's really important because the p-score demonstrates statistical significance, which essentially means that if you have a bunch of data, you want to make sure that it's statistically significant. You want to make sure that it's the independent variable, the change that's occurring in the experiment that's causing that data. And not confounding variables, not the other things. And so we want to have a really low p-score because a high p-score implies that there's a lot of your data is coming from confounding variables. In every discipline is different for their p-scores, but for psychology, we want a p-score that is less than or equal to 0.05, which essentially means that we want 5% or less of our results to come from confounding variables and 95% or more of our results to come from the independent variable, the change within the experiment itself. There are 6 steps to finding the standard deviation. You find the mean. This is literally just can be copied down. Find the mean, find the distance of each data point from the mean. So if the mean is 12 and you've got, a data point of 6, then that distance from that data point to the mean would be 6, obviously. You square the distance for each data point, add up those squares. You divide that number by the number of data points minus 1, which is called the variance. So if you have 10 scores, you find the distance from each of those 10 scores to the mean itself. You square that distance number for each data point, and then the total of all of those squares, you would then divide by 9 because it's the number of data points, 10 minus 1. And then from there, once you have that number, then you take the square root of that number. You're not generally going to be asked to find the standard deviation, but knowing kind of the general steps of how to do it can be pretty important. Most people use a calculator for the standard deviation. Finally, we look at the normal bell curve. The normal bell curve is something that's pretty important when it comes to statistics. This is what's used often in, say, like IQ tests, for example. And what we're looking at with this normal bell curve is an equally distributed curve, meaning that the mean, the median, and the mode is all literally in the center. In the case of IQ tests, 100 equals average, and so the mean, the median, the mode is going to be all directly in the center. Now, what you need to know about the normal bell curve is the percentage of people that fall within certain standard deviations. So, for example, you need to know that 68% of people score within 1 standard deviation of the mean in a normal bell curve or an equally distributed curve. 34% of them approximately will score above the mean, and 34% will score below the mean if the curve is equally distributed. 95% of scores come within 2 standard deviations, and 99.7% of scores are within 3 standard deviations. An easy way to remember that is a simple mnemonic little story. And that is a 6 and an 8-year-old are going to visit their grandma for her birthday. The grandma is turning 95, 6 and 8 obviously being the 68% of the first standard deviation. The grandma is turning 95, which is obviously the 95% of the 2 standard deviations. And she wants to listen to the oldie station, which is 99.7. And that's, of course, the 3 standard deviations. 99.7% of the population fall within 3. That's an easy way to remember it. Certainly, we can also remember that it's 34 on each side. It is 48 on each side if you're including the standard deviations, though if you're splitting them up, it's 34 and then 14. And then, of course, the 3 standard deviations come here at the end. Finally, we look at positively and negatively skewed curves. A positively and negatively skewed curves is when the mean, the median, the mode are not the same. In a positively skewed curve, what you find is that you have more data points that are past the mode, which is why it's positively skewed. So, I'm sorry, the mean is, there's more data points less than the average. Which is why it's positively skewed. The average is more than the more frequently occurring number. Negatively skewed, obviously, is the opposite. There are more data points past the mean. The mean is less than the majority of the data points, or the highest occurring number of points. But in trying to remember it in statistics terms can be a little bit tough because it gets confusing. The easiest way to remember it is that if you look at this shape, it kind of looks like a walrus or a whale or something like that. I know you have to use your imagination just a little bit. But if you add a tail onto this shape, onto your walrus or your whale or whatever you want to call it, the tail is always going to go at the end. And that's the way to remember whether it's positively or negatively skewed. Wherever the tail is, that demonstrates the type of skew. So obviously the tail on this top one would be down at the end, down at the very high end of the x-axis. So that would be your positive skew because it's all the way positive. It's very far from 0. Whereas the negative skew, the tail is going to be down here right around 0. So it's going to be even into the negative numbers. And certainly that's going to help you remember that the negative skew, the mean is less than the mode. If you have any questions, please feel free to email me about this. I know this can be a little bit confusing, especially if you've never taken statistics before.